we have a quartic equation to solve here, and we're given a complex root, 3 minus 5i. It immediately follows that 3 plus 5i is also a root. That's because it's the complex conjugate, and you always get those in pairs. I'm not going to prove that here, but it is a fact that you should know. Right, let's say, now here's the next bit. If a is a root, then x minus a is a factor. Actually, this is an if and only if relationship. If x minus a is a factor, then a is a root. You get both together, and that means if 3 minus 5i is a root, then x minus 3 minus 5i is a factor. So x minus 3 minus 5i, x minus 3 plus 5i is a factor, and I'm going to multiply them together because then I've got a quadratic that I can divide this by. Okay, and that's going to give us x squared, and then we're going to get minus 3 plus 5ix, then minus 3 minus 5ix. Here I've got a double negative, so it's going to be plus 3 minus 5i, 3 plus 5i. Bring this together. When you expand this out, we're going to get a minus 3x and another minus 3x. It's going to become x squared minus 6x. Meanwhile, I'll get a minus 5ix, but I'll get a plus 5ix, so the complex part goes. And then here, I'm going to get 9. Then I'm going to do 3 times 5i and minus 5i times 3. Those are actually going to cancel out, and I'll just be left with minus 25i squared, which becomes plus 25. So x squared minus 6x plus 34 is a factor. Okay, and that's great because now I can divide this quartic by that. Okay, actually it's quite nicely set up. So now we do a long division. Of course, you can do it by inspection or other methods, but I'm going to do it long division here. Here goes then. So x squared into x to the 4 gives me x squared. I multiply back through. Subtract. That's going to give me minus x cubed minus 36x squared. Bring down that 218x. X squared into this, go minus x. Multiply back through. Subtract. Here I'm going to get 252x. And finally, it's going to be minus 42, multiply back through, minus 6 times minus 42 is going to be 240 plus 12 is going to be 252. Of course, you can use a calculator for this. And 34 times minus 42, if you do that, you will get minus 1428. We get 0. We knew it was a factor. We had to get 0. Okay, that's good. So that means find the other 3 roots. So therefore, I'm actually going to factorize this directly now. This is going to give me minus 7 and plus 6. There we go, that's my fully factorized quartic. So roots, or additional roots actually, let me just check I've got the right one. So 3 plus 5i. Then I'm going to get 7, because x minus 7 is a factor, we're going to get 7 when this thing is 0, and minus 6.